Hi everyone, welcome back to our Netflix series where we talk about health and nutrition. Today we'll talk specifically about artificial sweeteners, and let's get right into it. So what are artificial sweeteners? Artificial sweeteners are synthetic sugar substitutes that are alternatives to regular sugars, including glucose, fructose, and lactose. These provide a sweet taste without the calories of regular sugar, as they are not metabolized in our bodies. They're designed to taste like sugar, act like sugar on our taste buds. However, since they do not contribute to the same metabolic effects, they're extremely popular in modern-day food industries and health-conscious diets. Chemically, these sweeteners have different structures, but they all mimic the shape and charge distribution of sugar molecules, allowing them to bind to the same taste receptors on our tongue. So how does sweetness perception begin? How does this process actually work? So when we first consume sugar, the mechanism of sugar detection begins in the tongue, which contains our taste buds, which are our sensory organs. These sugars bind to taste receptors on our tongue, including the T1R2 and T1R3 receptor complex, which causes a conformational change. This triggers a signal transduction pathway, and these downstream effects cause the activation of a G protein called gasteusin, which leads to the release of chemical messengers to the brain. The brain then interprets this as a sweet taste.
So here are three artificial sweeteners and their chemical structure. Artificial sweeteners mimic sugar by binding to the T1R2, T1R3 sweet receptors on the venous flytrap domain. They interact through three key sites, AH proton donors, B acceptors, and gamma hydrophobic sites, which together trigger the perception of sweetness. Starting with the most well-known, aspartame is a dipeptide of aspartic acid and phenylalanine. It's broken down in the small intestine, releasing its constituents, aspartic acid, phenylalanine, and methanol into the body. It is fully absorbed and about 200 times sweeter than sucrose. However, it is not heat stable and poses a PKU risk due to the phenylalanine release. Neotame is a modified form of aspartame with a tert-butyl group shown by the gamma site that prevents the breakdown into phenylalanine, making it safe for PKU consumers. It binds more tightly at the gamma site, is 7,000 times sweeter than sucrose, heat stable, and only partially absorbed before excretion. Finally, acesulfame is a non-peptidic cyclic sulfamate that binds using nitrogen and oxygen at its AH and B sites. It's not metabolized, meaning it is completely excreted unchanged. It's 200 times sweeter, highly heat and pH stable, making it ideal for baking and keeping things for a long shelf life.
The biggest challenge in using artificial sweeteners isn't just making things taste sweet. It's that sugar is a multi-talented ingredient. It provides a bulk in your cake, the texture in your ice cream, and the golden color on your cookies. Replacing all of that with a pinch of sweet powder is a fundamental problem we face. It creates three major problems. First, stability. Some sweeteners like aspartame break down when heated, so you can't bake with them. Secondly, the sensory issue. Some sweeteners leave a bitter aftertaste. And third, the replacement of sugar directly affects the product's flow and texture. It could make soft drink feeling watery and weaken the gel structure in jams. So, how do we solve this? One way is through formulation. First, we could blend sweeteners, combining two like aspartame and acesulfame, mask their individual aftertaste, and create a more sugar-like flavor. Second, we could add bulking agent like sugar alcohols. Although we are focusing on artificial sweeteners here, sugar alcohols are not a type of sugar substitute. Sugar alcohols' crystallization behavior and ability to form hydrogen bonds makes them valuable for improving bulking and moisture retention. This bulking agent restores the missing volume and the texture. There are other aspects like cost, regulation landscape, the safety standards, the interaction with aroma, and the product color. All these plays a key role in artificial sweetener use.
Let's talk about some health risks and benefits. So unlike regular sugar, they don't cause cavities because our oral bacteria cannot metabolize them, and also they were designed to help people reduce their sugar intake by providing that sweetness without the calories, and so they could be helpful for individuals struggling with obesity or diabetes. However, research has shown that this relationship is a little bit more complex, and so how beneficial are they really? Some studies have shown a link between increased artificial sweetener intake and a higher BMI, and even an increased infant body weight when consumed during pregnancy. So these effects may be as a result of changes in our gut microbiome and our glucose regulation. And these artificial sweeteners can also affect the brain's reward system. So these sweeteners are going to trigger the taste of sugars by activating our taste receptors. However, they're not going to have the same energy response because they don't have any calories, causing a reward mismatch, which can actually increase cravings and appetite and leading to the opposite of the effect that they're supposed to have. Overall, artificial sweeteners can be useful when consumed in moderation. However, they're not a perfect substitute for regular sugar at all. And because most of these studies are going to rely on short-term food recall, we need better long-term studies to be able to fully understand their health impacts.
In conclusion, artificial sweeteners are widely used as substitutes for natural sugar because they mimic the sweetness of sugar but are much sweeter, so only a small amount is needed to achieve the same taste. This makes them low in calories and suitable for people with diabetes or those aiming to reduce their sugar intake. However, the effect of each sweetener on the gut microbiome depends on its chemical structure. For example, neodymium and aspartame show no significant impact on gut bacteria, while azosulfame can affect the glucose transport system, influencing how the body regulates sugar levels. This highlights that structural differences play an important role, and more research is needed to fully understand their long-term safety. So there are several directions to improve the use of artificial sweeteners. First, we can develop personalized sweeteners, formulation of sweeteners that depend on one's microbiome, so to ensure a better and safer metabolic response. Second, researchers should aim to create safer sugar substitutes that reduce long-term health concerns such as cardiovascular disease. And finally, it's important to conduct more extensive studies and promote consumer awareness so that people better understand the ingredients and health impacts of what they consume. I think that's all. Thank you.